Our second lecture on the Earth will discuss the Earth's composition, atmosphere, and impacts upon the Earth. First, we will review the Earth's composition, and then we will go on to talk about the Earth's atmosphere and hydrosphere and impacts on the Earth. To review, the Earth's surface is composed mostly of silicon and oxygen, and earthquakes help us determine what's going on inside the Earth. As we said before, the Earth has 4 layers: the very thin crust, the mantle further in, the liquid core even deeper, and the solid inner core made of iron and nickel. Convection currents in the mantle push the crust along in plate tectonic activity. The Earth also has a magnetic field, the poles of which flip every few thousand years. This magnetic field, again, protects us from the cosmic rays and energetic particles of the sun. Now let's discuss the Earth's atmosphere and hydrosphere. What do we mean by those terms? Well, the atmosphere is a layer of gas which envelops the Earth. The hydrosphere simply means all the water on the surface of the Earth, which comprises over 70% of the Earth's surface. As for the atmosphere, the closer you are to sea level, the more atmospheric pressure there is. This is due to the weight of upper layers of the atmosphere pushing down on the lower atmospheres. As an analogy to this, there is a picture of several pillows here, and as you see, the lowermost pillows are compressed due to the weight of the pillows on top of them. There are names for the different layers of the Earth's atmosphere. The troposphere is where we stand at the lowermost layer. Even Mount Everest doesn't reach farther than the troposphere. Above that is the stratosphere, and farther up still is the ionosphere. It's interesting to note the temperature pattern as you go up into the atmosphere. First the temperature drops, then it increases again, then it drops again, and then finally it increases in the ionosphere. Part of this has to do with the fact that the atmosphere is becoming thinner, so temperature is actually a gauge of the motion of the particles, and though the atmosphere is very thin in the ionosphere, particles are moving very rapidly. As we mentioned before, the Earth's magnetic field captures charged particles and traps them in the magnetic field. When these charged particles interact with ionospheric particles, they create what is known as the aurora, or the northern lights. Two features of our atmosphere are: one, we have a layer which is called the ozone layer. This is a layer that helps protect us from ultraviolet radiation, which can be harmful to humans and other organisms. As you might realize, there is what is known as a hole in the ozone layer, currently above Antarctica, and it is worrying because it grows every year. The other feature of the atmosphere is the effect of carbon dioxide creating a greenhouse effect. This carbon dioxide acts to trap infrared radiation and heat, which warms up our surface. A little bit of greenhouse effect is a very good thing. Life as we know it couldn't exist without it. But too much of a greenhouse effect has dire consequences. As we will see later on in the course, the planet Venus is an example of a runaway greenhouse effect. Its atmosphere is comprised almost entirely of carbon dioxide. The more carbon dioxide we pump into Earth's atmosphere, the more of a greenhouse effect results. This is evidenced by what has happened to Venus. The more carbon dioxide, the more greenhouse effect, and the hotter the surface. One other word for runaway greenhouse effect is global warming. Global warming is a misunderstood term. It has nothing to do with your temperature at your location on one particular day. It has to do with the average temperature over many months and even years across the entire globe. Global warming is happening. It's important to realize that there is a consensus among scientists that this is the case. As this graph shows, the only debate about whether global warming is taking place is amongst the general public who have no particular background in climatology. It's important to understand that global warming is taking place because if we are to protect our Earth from possible consequences, we have to understand that there is indeed a problem. Other things shaping the Earth are the effects of water. Water covers over 70% of the Earth's surface, and it can cut through rock, carving great canyons such as the Grand Canyon pictured here. Let's go on and talk about impacts that strike the Earth. Have you ever seen a shooting star? Shooting star is actually just a small meteor which burns up in the Earth's atmosphere, releasing heat and light in its process. Most meteors never even make it to the ground. They burn up in the Earth's atmosphere, and we see them as shooting stars. However, when a meteor does make it to the ground, we call it meteorite. Meteorites can be comprised of iron, stone, or some combination of the two. Their appearance usually reveals something about their composition. There's a tremendous amount of energy released during an impact. This impact pictured here on Jupiter left an immense scar behind. Using the formula for kinetic energy, we can calculate exactly how much energy is released. And we see that it's based not only on the mass of the meteor, but also on its velocity. In fact, it's based on its velocity squared. So the faster an object is moving and the more massive it is, the more devastating the impact will be. For a 100 kilogram meteor traveling at 30 kilometers per second, the energy released would be equivalent to 10 tons of dynamite. This is a relatively small meteor. So you can imagine that very large ones release enormous amounts of energy. Giant impacts can still be found on the Earth, even despite the weathering and geologic patterns that act to erase them. Barringer crater is quite a sight to see. I recommend going there if you ever can. I went there once and it was really hard to take in the huge size. It didn't even look round from where you were standing. It just looked like a huge, almost like mountain peak or cliff. But from a distance, you see that it takes on a circular shape and is indeed a huge impact. Barringer crater has been well preserved because it's in the desert of Arizona. For very large impacts, devastating results can happen to living organisms. These are called mass extinction events. Such an event is thought to be what caused the extinction of the dinosaurs. A meteor about 10 kilometers wide was thought to strike the Yucatan Peninsula, which led to the destruction of the dinosaurs and many other life forms alive at that time. Mass extinction events have taken place multiple times in the history of the Earth and will continue to do so. Indeed, it is only a question of when, not if. Thinking about the fact that life is so tenuous here on Earth that it can be obliterated by impacts, or it can be devastated by our own hands, leads us to think again about the quote by Carl Sagan that we started with in our first lecture. It is important that we take care of the Earth and never, ever, for a moment, take it for granted.